Good morning, everybody. Good morning for me, anyways. I come to you from the nerd cavern, and I am incredibly excited today. I am so lucky and privileged that my fabulous friend Agna has put me in touch with Rob from the European Space Agency. I'm going to let him do the talking about this because he's the most wonderful space nerd you could possibly want to speak to about this. We are talking 3D metal printing in space. Like, I can't believe how lucky I am to be alive to see this happen. Yesterday, I had a wonderful chat with Miguel, who talked about his pancake bot, where we're literally talking about printing pancakes. And the next day, I get to talk to Rob about 3D printing metal in space. And so I'm going to welcome to the chat Rob, and we will dive into this stuff because you are going to love this. Rob, welcome.
A pleasure and an honor to be here, and thanks for the wonderful introduction.
Rob, would you mind just giving people, like, who are you? What are you working on? A little background first before we totally geek out about your fabulous printing.
Happy to do so. Hello to everyone. I'm working at the European Space Agency, born and raised in the Netherlands, in the coastal area. It's a very nice area. Working with the European Space Agency now for about 15 years, and the most recent 10 years in the area of robotic exploration, which is extremely exciting. The focus here for me is on making sure that everything we as European Space Agency have on the ISS, the International Space Station, and then it's mainly in the Columbus module, which is the European module of the International Space Station, is to keep all the instruments up and running, making sure that we can do everything we wanted to do with it. And as part of that, I've also been involved in coordinating the development of a metal 3D printer, which, as we speak, is in the space station from early this year onwards. And as we speak, we have or are still printing today.
It's just amazing. I mean, is this something I got to ask? Like, when you were like a little kid sort of staring up at the sky, were you thinking, oh my God, I can't wait to get up there and start 3D printing stuff?
I must say from young onwards, I was just thrilled with the aerospace domain. Yeah. I mean, I think it's also the apple doesn't fall far from the tree. My dad was working for the European Space Agency. So as a little kid, I was already in a position to visit the laboratories here. And yeah, I mean, then it was raised with that as an idea.
My father took me into the hospital to watch him do operations, and that just put me off everything. So
yeah, okay.
It worked for you.
Yeah, but it can work both ways. But that I would ended up with leading the development of a metal 3D printer, I would have never expected and anticipated at that time. I've never been eager to go to space, but to develop instrumentation for use in space, yeah, I think that was an early interest already. And I think by young, I already knew that I would be studying aerospace engineering and
right.
work for a space company. So here we are.
The way it's organized is really cool. We were talking about this before, but you're saying you're sort of put in charge of different sections of the space station. Like it's almost you have like a little room for rent, and that's where the various different equipment goes into.
You know, the International Space Station is a cooperation between different space agencies. NASA, the Canadian Space Agency, JAXA, the Japanese one, European Space Agency, and also Roscosmos, the Russian Space Agency, is still cooperating there. Each of these space agencies has their own module in the space station.
Right.
I mean, they're making use of each other's modules, but mainly their activities focus within. So the NASA activities and the NASA instrument developments will be mostly placed within the NASA module, the US module.
Right, right.
The ESA activities will be mostly located in the Columbus module. Then you have the JAXA module. Roscosmos has their own module, and as you can imagine, it's an opportunity, but it's also challenging to get everything working together.
Even just a roommate situation's got to be, you got to be interesting,
especially when it's getting crowded there.
Yeah, well, that's right, because you've got 2 extra astronauts up there right now, right? Is that until February?
Yes. Yeah. Well, we I think recently 4 astronauts came back with a SpaceX vehicle, and then with the recent launch of a SpaceX Dragon, only 2 new crew members came back, so they can bring Butch and Sunny back on the Dragon vehicle. So I think now there's about 10, give or take 1 or 2 in the station. Yeah.
For me, it would be a bit like being, oh no, I'm stuck on a wonderful tropical vacation for an extra couple of months.
I think it's the first. It's just being excited that they can extend the stay there. And I mean, of course, what you also see is that all the crew members which are going to the space station, they are very well trained.
Yeah.
So that means, and we're going to talk about it later, I can show you something about that for the metal 3D printer. The Suni and Butch, who were launched with the Boeing vehicle, were not planned to work on the metal 3D printer. Because of their extended stay and the opportunity to have more crew time, they could effectively be asked to do work on the metal 3D printer. So they're extremely well trained to cope with this kind of changes you have to the people on board the station.
I just can't get my head around the idea that, I get 3D printing. I have a number of them sitting here. I love the whole concept of 3D printing. But zero gravity? I mean, surely that throws a few issues, additional issues to this stuff. How does this work? And I guess, why does this work? Why do we even want to do this?
Let's first answer the question of why do we want to have a 3D printer anyway on board the ISS? Well, I think the first thing to say is that this metal 3D printer, and we also had plastic printers on the ISS, they're not so much there to make sure that we can print spare parts, that we can print special tools, etc. It's all there to familiarize with the technology and exactly ask questions like what you're asking. How can we print in space? What is the quality of what we print? So we have to do experiments to familiarize with this. And this is the reason why we have done this experiment. It's a technology demonstrator. We want to learn, how do you operate a printer in space? How do you get the quality that you can actually print spare parts? And the reason we want to do that, because if we're going to extend our missions to the moon and to Mars, you see, today, if something breaks down, and even if we have crew members stuck on the space station, a few months later, we can send a Dragon, we can send a supply mission, and we can supply to the space station. It's early days, they used to take 4 or 5 days to arrive at the space station with the orbits, etc. Now, sometimes they're there within a day and they can attach to the space station and unload. So there's not really a reason why we should have to print this on space, because it's expensive. It requires an expensive instrument and an instrument which is bulky, it's large. But once you go to Mars, then you cannot resupply anymore. You have to send a container with the same speed to Mars as the space habitat. You need to have something on board. And then, of course, you can think about make things as reliable as possible. And it's going to happen anyway. It's happening today. We make everything as reliable as possible, or bring a lot of spare parts, but you cannot bring all the spare parts you need, because then you basically need to have a warehouse with you to be able to collect your spare parts. So 3D printing in space it offers a very interesting alternative. But I mean, we do need to go through a lot of steps before we can say, okay, we can really manufacture spare parts in space.
And they've used it. I saw there was an article fairly recently about, I mean, it was something fairly trivial, but it was like they needed the right size wrench for something. So they 3D printed a little hex wrench that would work for them. Talk about 3D printing for a second here, because there's a number of different ways of approaching 3D printing. I know we've got, I think the ones that most people are familiar with probably is literally just melting plastic and moving the head around to create. It's basically a giant glue gun that you can slowly put layers down. What are the types of 3D printing you guys are using there?
For the metal 3D printer, we are using a technology called direct energy disposition. So basically what you do is you heat an area of your print, where your printing area, you heat the metal.
Right.
And when you heat the metal, and we do it with a laser. But you can also do it through electricity. You can do it with a coil.
But lasers look so cool.
But be careful with a laser, because we have a 1 kilowatt laser there, and it has to create a temperature of 1,400 degrees Celsius to be able to melt the metal. And then what we do, once we melted the metal, we put a wire in it. The wire will melt a little bit. We retract the wire, and then this melting pool, together with the wire which we added, will solidify and add some material to what we call a base plate.
And how do you stop it from floating away? Like, how do you stop? Because if you're actually melting stuff, why is it not? We've all seen the movies where the stuff floats away.
Yeah, well, it's partly because of the internal forces in the metal, the attraction. It's the cohesion of the metal melting pool with the underlying metal. That's quite strong, and that's very strong as opposed to that you're only melting a very little area. So the mass of that area is extremely small. It holds itself together.
But if you did too much melting, it would become a blob and float off.
We've experienced that. Yeah.
Oh, really?
Yeah. We managed to get rid of the blob because we experienced it. But that's part of what we want to learn.
But how do you get rid of the blob? Does it literally take one of the astronauts to go in and grab it?
We actually use the laser for that. We use the
laser
to cut the blob from the wire. Yeah.
Oh, that's great.
Yeah.
That's got to...
Or we create a melting pool on the material and we melt the blob in the... So it depends a little bit on the situation. Ultimately, if we would not have been able, we were able to do this, but if we would not have been able to do this, then we need crew to open the sealed container where the printing is taking place.
And that's not generally I'm guessing that's not as simple as just like, it's done.
No. It takes about 4 to 6 hours for crew to retrieve the printer from its location, open the sealed container, because the printing needs to take place in nitrogen.
Right.
So you cannot print in oxygen because then it will burn. So we have to create kind of a vacuum chamber or a sealed container where we remove the air and we put nitrogen to be able to print. And so we also need to do a lot of preparations before crew can even reach the wire to cut it.
Right.
And then that's
it's all
one of the challenges.
Basically, for the most part, you try to keep it all self-contained. It works for it. It looks after itself. How you're monitoring it with cameras and stuff internally?
Yeah. We have a video camera, and I might be able to share.
Please,
photos
yeah.
that.
I used to joke that you could watch an ocean forever, you could watch a fire burn forever. Then it became like, baby sleeping was something that was just wonderful to watch when it's your own child, especially because they're sleeping. And then 3D printing. I could watch 3D printing, and I will often just sit there watching these layers get put down. There's something almost sort of primal about this idea that there is a machine building something for me.
Basically what you see, this is real time. So this is not, I can show it later, but this is what happens. So we have a video camera there. And then once we have printed this is just prints like the lines which are done prior to when we're going to start the sample, because we want to check, is this printed okay? You see the lines, and some of them are not printed that well.
Right.
So then we can make corrections.
It's your layer test. You're doing a layer test on the...
Exactly, yeah. And so we have a video there, who is also taking the pictures to see. And then there is a laser, a small power laser who scans the surface of the print.
So when we're seeing it, when you're seeing it lay down this layer of, it's stainless steel, you said, is that right?
This is stainless steel. Yeah.
So the laser is above somewhere, or where is it actually hit? Yeah.
This is the focal point. So the heated area is the focal point of the laser, but the laser objective, so the which focuses the laser on the printing area, it's about 5 to 10 centimeters away from the printing area.
Wow.
And you have to be, and that's also for a reason, because you can imagine you have to heat up the printing area to about 1,400 degrees centigrade. Celsius. If the sensors would be too close, you might actually damage the optics of the laser. So we have to really make sure that this is kept up and running during the printing.
This whole experiment is running beside people living in space, right? The safety has got to be, you must have thought of everything. You've just basically got to go, what if this goes wrong? What if this goes wrong? What if this goes wrong?
It's actually, there's procedures for that to go through all what are the possible hazards which would happen, and especially when you have a laser, then our safety board is very, very.
My wife made me buy a fire extinguisher because I started using the laser cutter here, and she's like, "No, you need a fire extinguisher."
That's the reason for that.
That was it. Yeah. So,
and also, if you're printing metal, there's certain fumes which are from the metal, which could be toxic.
Yeah.
So you also have to make sure that you have the proper filtering. etc., etc. And this has been the discussion when we had this kind of bulb on the end of the wire.
Yeah.
We wanted to see whether we could cut it, and even cutting the wire needs a safety assessment whether we can. So we very much value the well-being of crew as well as the space station itself.
Right.
I mean, can you imagine that if the laser would go out of the printing area and hit the wall of the space station? I mean,
it's definitely something
about that.
My Stargate character might have done something like that. I could see. Oops, sorry, I took off that part of the space station. Yeah, I mean that's. Yeah, I mean, God, the more I think about it, the more I struggle to figure out how you make something like that happen. What is so ESA? Are they? I'm assuming they've just got a series. They've got a system in place that people just run through everything they have to do. There must be some kind of a system in place for that.
There's procedures in place, which when you basically have the idea to start developing a metal 3D printer.
Yeah, whose idea was this? Where did this come from?
That goes far back. I think it's partly it comes from discussions from when we're talking about the future of space exploration and what's needed in support of that.
Right.
People would come up with, okay, we do need an in-space manufacturing capability. I mean, you were talking about on the moon when you're trying to build habitats there.
Yeah.
Is 3D printing an option with the zeolites which are on the moon? So at some point in time, when you're going to look at what's needed to do in-space manufacturing, the idea of plastic printers, metal 3D printers, but also post-processing equipment. I mean, we're also trying to support circular approach. So maybe we can recycle failed components. So
that was fascinating. Yeah, that was mentioned early on with that, wasn't it?
Exactly. So the ideas are coming from, I would say, overall high-level discussions on future exploration strategy and what's needed in support of that. Another thing is, how do we feed crew who are going to Mars? Because it's a 1.5 year trip. Then they have to wait for half a year, 1.5 year back. How are you going to feed them?
We've got to grow stuff, right? We've got to be able to create our own food.
But there we also have this sometimes crazy idea. Can we use this concept of cultivated meat? Can we use this concept of proteins which are produced by using bacteria? What is the footprint of these kind of technologies as opposed to bringing everything? So, and we're in the early phases of exploring these kind of technologies, whether they would work in space. And in this respect, this is looking at a 3D printing metal. And it's like, okay, we're starting from scratch. What do we need? What do we have to take into account? And of course, the samples which come back from space will, and I can maybe show you a picture.
Yeah, what are you printing? Like what? So you've got your first print of a metal printer.
Well, that's why you say, well, when people were asking you, well, it's not possible to print, I can safely say, without any hesitation, yes, we
You've
can.
got photo proof. Look at that.
So this is printed, and we also got questions. What's this? These are tensile and bending samples.
Right.
So why are we doing that? It's to understand what is the quality of printing. So these stress samples and these bending samples will be removed from what we call the substrate, so the base plate. They will be machined to certain dimensions, to predefined dimensions. And if we have these samples, we go to pull them apart and see how strong are they. We go to bend the small ones, bend them, how strong are they? And then we're capable to compare it with what we have printed on Earth.
Right. So you've done the same print on Earth.
Yeah, we've done it already.
And so I guess the cleanup is just to make sure that everything is a consistent like width and height.
Exactly.
That's right. Yeah.
So we can, I would say, scientifically compare them and make some initial conclusions about the quality of printing in space. So I think that is one of the things we really want to get out of this. And by having printed this part, and we're printing 4 parts, we're still printing now another sample which looks different, and then there's got to be 2 others. But by having printed this one, we can already start investigating what's the quality. The other thing we wanted to know is, how do you operate such a thing? What do we learn? What do we have to take into account?
Right.
We've missed a few things in the development we know now. So when we are going to do this for real, I would say, so when we're really printing spare parts, then we can do this a bit more reliable than what we have done now. This took 25 days. And now people will tell you, because you saw the previous movie, and you see that the printing itself is going quite quick. You look at it real time. This took 25 days, and there's a few reasons why it took so long. First of all, we're not allowed to print longer than 4 hours, approximately 4 hours per day, 5 days a week.
And that's because
there are limitations,
right,
depending on how much noise you generate in the space station, how long you can operate per day. So now we're discussing with our international partners that if there's no crew in the Columbus module, would we be allowed to print a bit longer?
Wow. This is a bit like having the list on the fridge with your roommate saying, like, who's got the PlayStation tonight?
The other reason is that, I mean, you see a little bit in this photo, you see that there's layers. These prints are 218 layers. And after each layer, we want to have a video recording. Right. We want to have a surface measurement to see whether we are printing in line with what we would expect.
Right.
These have to be transmitted to Earth, which sometimes can be done directly. Sometimes it takes a little bit of time before we get them on the ground station. Right. They have to be analyzed. And based on that, they say, okay, we continue with the following layer. So now one of the things we're actually discussing to do, maybe not in space, but we also have a printer on ground, is to see whether we can use some automation together with a digital twin. So we do some artificial intelligence. Right. Who can actually analyze the video and the surface measurements and directly determine, okay, then we print it like that. And then if we print 24/7, we got to substantially reduce the duration of printing.
The digital twin thing is hilarious to me because I just think whoever used that, we have to come up with a better term than that, because that is just so ripe for sci-fi to destroy. There's always one evil twin, right? So it just allows us to do things faster than it takes in the real world. I mean, with robotics, that's a big part of it, because the fact that you could have a robot run a test 1 billion times overnight, in the real world, there's only so many hours in a day that you could get a robot to run that test. Are people literally just looking at the photos and going, yep, okay, great, next one?
Yeah, the AI is now still with humans.
Really?
We're thinking about the next steps, but we did this, that now humans are looking at it because we want to learn from it. So also the people are building knowledge about, okay, how are we going to do this and how are we going to correct? So also the team, and that's a team which is working from Toulouse in France.
Great place. Fabulous place. One of my favorite conventions was there, the Toulouse Con.
I'm hoping to be there early next month to witness the day-to-day operations for printing, because once in a while I prefer also to be in that environment rather than in the office environment here. Right. Get the pictures at the end of the day.
Gets you out of the office, gets you a bit of French food. I mean, come on.
Exactly.
Yeah, pick up the cheese. I love the cheese. Agna, our fabulous Agna, who's basically spearheaded this entire thing, has volunteered to check the questions for us in the chat. Martin asks, hello, Martin, says, how fast is the metal printer on the... Oh, we sort of touched on that. It can go faster, right?
I can also tell you a little bit about the size of what we're printing, because that, I would say, is information.
The lasers melting metal in space is just always kind of a fun thing for people to watch.
I can keep watching this all the time. And
yeah.
I have another video of actually what we've printed, but that's not a video. It's a GIF. And when I open that, it's only pictures, so it's very difficult to share it. When you're looking at the S, it's in the order of 1/2 to 3/4 of an inch. It's 2 centimeters.
Oh, really? I didn't realize this. Okay, so it's a fair size.
Yeah, the sample I showed you, the picture which was held by crew, we can print a shape within the volume of a soda can.
Right.
So and that's. Of course, that can be extended. It can be made smaller, but this was what we choose for this technology demonstrator.
Well, and that's how the 3D printing, the whole consumer 3D printing thing started too. It started with these smaller printers, and they've gradually got larger and larger and larger. My joke is always that there's no, like tattoos, no one ever gets one 3D printer. Like, no one ever gets one tattoo. They always, I always have to have and I end up with 1 million 3D printers and no tattoo.
Well, let's see at the end of my work at ESA whether there are multiple metal 3D.
There you go. That's it. You'll know.
Might not be the case.
So, Martin, hopefully that answers your question. You've literally seen how fast it can print. That is it in action there. But the need to, quality control and safety and stuff means that it's obviously a slower process than what the machine is actually capable of to start. Hey, Nixie, he's got a question. It says, I hope ESA is a good place to work. What was your most fulfilling day at work there?
I can only confirm that working at ESA is extremely interesting. I mean, I'm in the middle of everything, what's happening on the space station, being in it day by day, sometimes also working with the people who've been there to understand how they've experienced the projects, the activities. So, yeah, I do appreciate very much to get on the bike or in the car in the morning and go to work. Most fulfilling days, I think the one when I got the video which I just showed is that we managed to get, after 5 or 6 years of development with all kind of challenges, to manage to get the printer on board and to see the first actual print being done. I must honestly say it was fingers crossed, because it is a technology demonstrator. We used a lot of commercial off-the-shelf equipment. I mean, safety is very strong, but in terms of reliability, we really were trying to keep the budget as low as possible to learn. So to see this, and then the second best day is when the first sample was returned from the printer by the crew, and everything worked.
Yeah. That's amazing. I mean, I can verify this. Whenever I talk to Rob, he looks annoyingly happy all the time.
Is it annoying?
No, just because I'm jealous.
I have to live up to my nationality here, Dave.
That's it. That's
so
true.
We cycle.
That's true. You got to cycle. You don't have a choice. I've got to eat bacon. That's all I have to do because I'm Canadian.
Okay.
So thank you, Nixie. All right. AB solution. EAB, very good. AB testing. How are the metal printers powered on the space station? Power was actually one of my first questions. That's true. And maybe you could explain how the power situation works on the space station.
Well, I think the first to answer is that, in general, the power supply on the International Space Station is coming from the solar panels, which are on the station. And please be aware, I don't know how many kilowatts they generate. You can find it on the internet, but they're the size of a few football pitches. The power which is generated by the solar panels is then distributed to the different modules. So the US, the JAXA, the Japanese, the Russian, the Canadian, and the ESA module. And then within that module, there is a power distribution to the different instruments which are in the Columbus module. And to make it very precise, for the metal 3D printer, we have about a budget of 2 kilowatt.
Wow. And so they must be. They're storing this power? Do they store the power on the station, or is it all just directly?
Oh, that's good. I think they might have some batteries, but mostly they need to have the batteries for the time they're in the shade of the Earth, and don't have because they're not in a polar circular. They more or less have some outages and dark sides, and then they need to have the continued generation. So yes, they have batteries.
But so when you're running, you're probably not running the metal printer unless you're actually directly getting that power.
Well, no, we are running because if you're looking at 3.5 hours of operation of the metal 3D printer, one turn around the Earth would take about 2 hours.
Yeah, so, I keep forgetting it's moving crazy fast, isn't it?
Yeah,
it just looks all floaty and peaceful.
It's about 6 kilometers per second or something. 2 years ago, I gave just an introduction on a primary school, and also for 6 to 9 year olds, just to make them understand the concept of the speed these stations are going at. It's basically, you tell them, well, from my town to the airport, which is about 20 kilometers, it takes you 3 seconds. Yeah.
I mean, you're literally hurtling around the planet. And 3D printing at the same time now.
You see quite a few sunrises and sunsets per day.
Yeah, it gets boring after a while. There's another one. Wait 5 minutes. Going. Thank you, AB Solution, for that one. Martin has got a lot of questions today. Do you also do a standard? Was it fused deposition and FDM? What is that? I can't remember the term.
Yeah, that's for me. It's also
standard FDM printing, either for yourself as a hobby or for ESA. So, are you doing 3D printing yourself? I mean, is it something you use in your sort of day to day?
Nope.
No.
I think it's extremely interesting. And sometimes when I pass a shop where you have these plastic 3D printers and you can see what you do with it, I'm thinking, this could be interesting. But
you should maybe print a space station, even just so you've got one for yourself. That little, something. I keep meaning to do a print of it. I've got the rover.
But that would be nice. And quite honestly, you also have the opportunity to make your design and go through a 3D printing shop, like a printer shop. For me, it was also a bit of a choice of, okay, what do I focus on in my free time? I'm sorry to say that 3D printing didn't come in. For ESA, we do have 3D printers here, and we're making use of them. But maybe what is also good to mention is that we're not only investigating as ESA 3D printing in space, so actually making spare parts in space, but we're also investigating using 3D printing solutions to print parts for rockets, for satellites on Earth when we are building them. There's a company recently 3D printed a rocket engine with all the tubes inside, with the cooling inside, with the guidance inside, and they're actually doing tests with that. So,
Wow.
yeah, a colleague of mine who is working more towards the technology support and the materials section, he is looking into all kind of space or 3D manufacturing solutions to be used when we're developing equipment. But in the end, there's a lot of benefit to printing things in space, because if you print things on ground or you manufacture things on ground and you're launching it, you need the stuff to be very strong because it has to survive a launch. And if you print it in space, you don't need this strength anymore. So you can print at much lower mass, and that opens a lot of opportunities. But yeah,
there's medical printing too, isn't there? Do some medical printing on the station that basically can't be done unless you're in zero gravity.
Nice that you mentioned it, because one of the projects, and I'm actually a bit disappointed that I'm not involved in that, but we're developing a 3D bioprinter.
That's amazing. That stuff is extraordinary. I mean, it's funny. We had a discussion about this. I did a panel on science and sci-fi with a sort of more of a focus on biology over the weekend. And one of the things that came up was the idea of like, what do you think? What about the future of bioprinting? And I was saying I felt we were more in the realm of these chimeras, these, using other animals to create them, rather, because the 3D printing is such a detailed and lengthy process. But the idea that it can only be done up in space is fascinating. I mean, so you couldn't jump ship from metal to bio. You couldn't do that.
Wow.
You're working on it.
Unfortunately not.
Well, you're now the pro on 3D printing. Can't you sort of go like, yeah, been there, done it? No.
I would actually love to continue with the next steps.
Yeah. What are the next steps? Like, what is it? So you've done this. I mean, you print a space station next? What's the next?
There's a few ideas, and I'm afraid it doesn't reach to printing a space station yet. You saw the quality of the print. That needs improvement.
Yeah.
So we're looking into that. We're also looking into post-processing. So as soon as we have printed some things, do we need to process it? So we're really looking at the manufacturing process itself. So how the 3D printing itself, then today on how we're going to use it to print. For now, this kind of printer is more for spare parts, small tools, or small construction parts.
And like a proof of concept. Yeah, that's not.
So this will be the next steps. I mean, it's very much depending also on when a mission to Mars becomes reality. I mean,
right.
There's a lot of activity going on to see how this would work. But there's also still a lot of investigations needed to see that it would actually work.
Right. Like on Earth, I know with gravity, the larger these things get, the harder it is to make them more precise. Is the same limitations when it comes to...
There's definitely, you can resize. To what extent? I think you have to realize that we are printing in a sealed container, which needs to be strong. And as this gets larger, it gets more and more challenging to make these kind of sealed containers, especially when you're starting to work with pressure differences. So this is one which could be a limitation. Then, of course, you need to move the sample with respect to the laser. So how much space do we have there? And one of the issues we actually encountered is that the further we came with the sample which we have printed, the more challenging it became to get rid of the excess heat when printing.
As it gets closer to the laser, it becomes harder to get rid of the heat? Or the heat is just transferring down?
No, the laser is always at the same distance from where you print. That's done in this, but it can change. I'm going to share this because then maybe with my pointer I can explain it a little bit better. This is the base plate. So when you start to print here, your heat gets immediately to the base plate. So you have a lot of volume. But when you're printing here, the heat has to go through.
Of course, it's not going to dissipate nearly as fast, is it?
Yeah, so we do have an airflow to cool it down, but it's going to be more and more challenging. When we had the movies of printing this, we saw that the closer we came to the end of the print, you saw the remaining layer still glowing a bit from cooling down.
So that's fascinating. All these little things you just wouldn't think of, right?
No, and to be honest, this is also something which, I mean, in space, when we're developing satellite, we try to think of everything if we develop it, because we have one chance to make it a success.
Right.
With the metal 3D printer, this was a little bit different. So this is also something we discovered when we were looking at the video. And people were saying, I'm like, things are still glowing. What's the matter? And then analyzing this, we said, yeah, but we have to for next time, we have to see how we can solve this.
Right. The fact that you're talking about airflow in a place that there is no air. So you're printing in the space station. Is there not a way to use the fact that it's freezing cold and there's no air outside of the station? I mean, is this something that was the reason why? Like, why do the 3D printing in the station? Because you have to get to it. Was that it? Is that purely just a matter of that?
Yeah, for this specific 3D printer, this was one of the reasons is that we need crew to install it. And I
was thinking that it's so much more automated somehow, but I guess the fact of the matter is you still need people to plug things in and and screw things down and all that kind of stuff.
You still need it in the station too, because it's a technology demonstrator. When we go to a next step, we might see whether there could be a mechanism which is automatically capturing the printed part and placing a new base plate for the next part. That could very well be.
But keep it simple to start. In the 3D printing world, they talk about printing benchies. Have you heard this? The benchy is basically it's just a little ship. It's a standardized way of looking at a 3D print. I don't have to because I think I got rid of them. But they're literally, it's just a little 3D printed boat. And the idea is basically that you print that on any printer you've got and you can compare that. So basically you printed your first space benchy.
That idea is actually very, very good. And something we can take along is that all along the printing you're doing, that you have some kind of benchmark or reference where you say, okay, how does the next generation of 3D printers in space compare to the one we had? Yeah. How does the quality improve over time? So that's actually a very good concept.
With the FDM printers, it's really funny to see, like the first ones, you could definitely see layers. And as they got progressively more sophisticated, the layers disappeared. We should go back to questions, sorry, because I'm hogging you totally here. So, Martin, no, not a lot of hobbying of. You're actually, this got you a great segue for your hobby actually, because Rob is huge on wildlife photography. When you want to get away, that's what you do now, right?
Yeah. It's just in the spare time when I just want to disconnect.
Yeah.
I go hiking with the camera in my backpack and see if there's something to capture or not.
And the photos are just beautiful too. Just absolutely. I just love the fact that you're cycling to work to do some of the most sophisticated, complex stuff that humans have ever done. But on the way, you could stop off and take some photos of like foxes and things. You know what I mean?
Yeah.
Another question. What are the steps from design to final part for a metal 3D printer? I know from experience that it's quite different from FDM. So what are the steps from design? What do you design this stuff in? Is there a software or is it just literally just programmatic at this point?
We start usually from a cut drawing. So from any cut drawing, there's a standard format for that.
Yeah.
And then
are these STLs? Are you using STL files for it? Is it?
I think it's an STL file.
Oh, great. Wow. Okay. That brings it home.
So it's the standard exchange format for 3D designs.
Yeah. So G code.
And then this design is fed into kind of a translator, which translates the 3D shape into what we call a G code.
Yeah.
And the G codes are actually the codes which are fed to the metal 3D printer.
Just the instructions on literally where to move and where to
Well, it's the instructions on where to move, and of course this processing software needs to be tailored to the specific, I would say, layout of the printer and design of the printer, because in our case this G code file also switches on the wire feeder. Right. It says, well, feed the wire with 1 millimeter, retract it with 10 millimeters, etc. It's also moving the table, and in the end, it's the G code. We have also automatically processed or take the picture.
So all that is custom, I guess, custom G code you've got to build into the system. Are there comparables? I mean, obviously you've got your own, evil twin back on Earth, but what about in the regular world? Are we using this technology for other things here? And are we doing a lot of like 3D metal printing? I mean, it's not something I'm really aware of. I've seen some welding stuff, but
we're definitely increasing the 3D printing on Earth.
Of the metal.
And stainless steel, I think in a few weeks, I'm going to visit a kind of a fab lab, so-called fab lab, close to where I live, where they do 3D printing, and part of it is metal printing, and they recently got a titanium printer there.
Oh, wow.
So, I'm actually very much looking forward to that. I usually see it as kind of a cross-fertilization between the terrestrial application and the space application. Right. So we can use and we benefit from using some of the terrestrial technologies. Yeah, exactly. Sometimes we also have to tailor it a bit. For instance, to meet the safety requirements, to meet the environmental requirements. In the station, we are lucky to have a nitrogen supply.
Right.
But for instance, we don't have an argon supply or a neon supply. So
Yeah.
we cannot use a printing methodology which uses one of these inert gases. So we had to tailor it to using nitrogen as a protection to prevent the printing from burning. We, of course, gained the experience now to do printing in this way. And we are also aligning them with the terrestrial applications to see how they can benefit from that.
So it improves both, basically.
Yeah. One of our challenges is that we have to make it small.
Right.
We cannot, this is about a meter high, 40, 50 centimeters wide, and 60 centimeters deep. If you look into a factory, a metal 3D printer, I mean, it takes up a room.
Yeah.
We cannot fly that. So we've managed now to get this, and this is very exciting because we make it small, which means that if this works in space and we could apply it on Earth, then, and maybe not the metal 3D printer, maybe it's a plastic printer, but if you have these small pieces of equipment requiring 1.5 kilowatts, requiring maybe some cooling, maybe if there is an emergency area somewhere on the world because of a natural disaster or something, and something is needed to quickly deploy constructions, you have a small piece of equipment which could actually be done there. And that's also part of the cross-fertilization we have. And we also do this with the same food solutions. We need small solutions for producing food for crew. Right. Why not use this on Earth in areas where...
We do need to eat here too. Yeah.
Even in these emergency services, if you have a small piece of equipment, like maybe the size of a container, which can quickly support in emergency areas people in need, then you can benefit from these miniaturized technologies.
And self-contained technology too, right? Because it's designed to be modular for the station.
3D printing might not be the first thing you think of when you're going into an emergency response, but still the fact that we're developing miniature solutions for different technologies could be helpful there. And we're trying also to encourage industry to take up on that.
Yeah, how does it work with that? This stuff is being invented by ESA and in partnership with Airbus, is that right?
ESA is an agency, it's a procurement agency. So we draw up a space program, and every 4 years we get funded by our member states, which at the moment there are about 22 member states, most of them, if not all, in Europe, to a large extent overlapping with the European Union. And we agree with these countries a program of different activities, and then we contract these activities based on the funding we get from these countries. We contract these activities to industry in Europe.
I see.
And in this case, Airbus leads an industrial team who have developed the printer for ESA, and then they deliver. So ESA is the owner now because it's been delivered, but it's been developed in industry.
But does that mean like patents and stuff can be made public, or I mean, how much of the stuff can be
on a case-by-case basis? If we're really developing forward IPR in a project, so actually we're developing knowledge which could be commercialized in a project, then ESA has the right of use.
Oh, great. Okay, right. Okay.
But it's also the industry developing has a right to keep the patent. So we will not be in a position to say to everybody, hey, this is what this industry developed, unless there's a prior agreement to that. Any knowledge before which is with the industry is the same.
Right. Okay. Any applications for Blender aside from industry standard CAD, CAM software like SolidWorks? What other software would be in use, and are there any applications for Blender? Have you ever played with Blender, the 3D? It's open source.
No, that's why you see a few big question marks on my face.
I am fascinated by the open source tools that are out there, because one of the things I love with Tech Bandits is that I want to be able to show, I want to get people excited about stuff, but I also understand that not everyone's got the money to invest in these CAD CAM softwares can be quite expensive. The Blender is an open source version, which is extraordinary at doing a lot of this stuff. It's a lot more complex than some of like the Fusion 360s and stuff in some ways. But I think we've touched on that. You're basically using standards up to the point of the G code, which then needs to be customized for the specific machine. But you're saying that they were designed originally in just classic CAD software.
Yeah. That's also the inputs we provide. So we have asked for the industry to print specific parts, and we provide this industry with sometimes a drawing only, but in most cases with a cut file.
Right.
And they process that. Sometimes they process it first into a cut file a little bit more detail, because we also do have a lot of discussion on whether what we want is really feasible. Because, I mean, this is a 4D printer.
Right.
So it has a 3D motion table and then a rotation. The next step we might also consider to be able to print even more complex shapes is to make it a 5D printer and also see whether we can, for instance, move the laser head. But that's going to be challenging.
Yeah,
So
I can't get my head around the code for that.
Yeah. I'm also in discussion now with Airbus on what would be just on the back of an envelope, but what could be ideas to how we could realize that, and would it be interesting? So we still have to balance it against what do we really need in the future.
And what is the pressing need? I mean, what is the sense the sense you get from ESA right now? How important is the 3D printing in the scheme of things there now?
3D printing in general, because you only need to bring material and you can print anything which is needed at that moment. So that's the advantage, and then you can either decide to do plastic printers or metal printers.
Do the plastic printers work the same way? It's the same idea basically. Things aren't floating away because they're held in place. Yeah. The surface tension.
And we had a few printers already back in 2014 on the station, which were mainly from NASA.
Right.
And yes, some part of tools, as you were saying. So this is one of the things we can do. And then the specific parts which have to be printed is very much depending on which spare parts we expect would be needed. Some parts have a limited lifetime. Maybe we have to print them after this limited lifetime.
Right.
And you may also need it that when you have to do a specific repair in space and you don't have the tool, is to see whether you can print the tool on demand.
Right.
And also if you're developing constructions, and there I can't say what is the specific part, but depending on the construction, every large construction needs smaller parts in it to connect larger parts to be able to provide attachment points, etc., etc. And here a 3D printer, whether it's plastic or metal, I mean, metal is there for strength, metal is there for conductivity, but alternatively, if this is not really needed, then a plastic printer at this time might be a better solution.
Also jigs and stuff. I find like creating little custom jigs to hold things temporarily and stuff. I think the 3D printing is just fantastic for that kind of stuff. Agna has a question for us here, which I think is a good one. Airflow. When we talk about airflow, how do you achieve airflow in the space station?
It's simple. You use a fan.
But literally that's it. But you're just using, so you're using the air that they're using for just breathing in, and
No, I think this was indeed, maybe I didn't make myself fully understand. I think I haven't shown the beast yet.
Yeah, sure, here it goes. The secret is out.
So this is it.
Oh, wow. Oh, my God.
Yeah.
Oh, that's a nightmare. Oh, my God.
Yeah. So,
wow.
If you see this part, this is a sealed container.
Right.
This is, well, to put it popular, is where the magic happens.
Right. The rest of it is the nightmare around that magic.
This is the nightmare of electronics and liquids, etc., and all kind of flag lines, trying to get the cooling done, etc., etc. So here is the sample, which is on the motion table. This is the laser head.
Okay.
And here you see a fan. These are fans.
Right.
So basically, we close the sealed container.
Right.
So then the sealed container has just normal air inside. Then the first steps we do when we want to start printing is remove the air and replace it by nitrogen.
Right.
So then we create, and that's maybe the misunderstanding, we don't create an airflow in the sense of air, we create a nitrogen flow. So basically the gas flow of nitrogen is created here and is cooling down. So this is how we create an airflow.
Is nitrogen better at cooling than air?
No, I don't think so. It's with the printing process that we don't burn the print.
Right.
The oxygen level is going down to 0.15% or something.
It's very, very low oxygen, basically no oxygen.
0.5% O2 at 0.88 bar. So we create a little bit of under pressure. So that means that the sealed box, the seals here are pressing against the box.
Right.
So we create a very good air tightness.
Right. Right. God, that is a beast. It
is, isn't it? Yeah.
And so what's required when that thing goes up, which unto itself is, I mean, I almost need a human for scale, but given the rotating head that you're printing on is the size of a Coke can, you said, right? Or was it a can of pop, that you get a sense of the size. When, no wonder you need astronauts. How much has to be configured once it gets up there? Like when it gets in there, what do they? I'm assuming it doesn't just slot in.
No, it doesn't. So here you see the blue parts.
Yep.
These will be installed to fix the motion table.
Okay.
So they survive the launch. These have to be removed.
There's the styrofoam inserts on my microwave. Got it. Okay. Yeah.
Otherwise, they might get damaged. So we really ruggedize the 3D table. Then there is a wire feeder which needs to be configured. Some caps need to be removed.
How much wire are you bringing up? Is there like just a spool of it somewhere? Or
yeah, the spool is in here. And this brings, we brought 1 kilo of wire.
Right. Okay.
So, and we are using between 100, 120 and 200 grams for 4 samples.
Right.
So we are still left with some spare in case it's needed, or if we are successful to start thinking about another sample to be printed.
So when it gets up there, it has to be connected to the system. And I'm assuming we talked about this before, but basically you're provided certain outlets for power and air and such, and that just needs to be, that is all just done manually plugged in, basically. Dixie has a question about the metal printing on Mars, which is a great question. Is there research into the mining of steel and such on Mars, making the metal on that planet to do the printing with? Like, so you're looking to get. One of the things you touched on, which I thought was fascinating, was the idea of using existing metal, which I'm guessing is from space trash and stuff. I mean, what?
Could be space trash, could actually also be something from mining. Some colleagues of mine at the European Astronaut Center, they've managed to print a Lego block from zeolite, which is the moon dust.
Oh.
So they basically extracted the material from zeolite. They have some Earth-made zeolite there, which is to a large extent based on the zeolite which was brought home by the Apollo crews.
Right. It is like a little playroom of the stuff that they've made. Right?
Yeah, I think you can call it a bit of a playroom because it's playing there, melting the material, extracting necessary components from that, and within the space domain, this is called in-situ resource utilization, is to see whether we can actually use the resources which are available on the moon and Mars to support in producing the stuff. We can't bring everything, but then it takes a long time.
There was another article I saw recently about a proposed satellite that would basically build itself in space. I know that's been done in parts before, but this is literally, they were talking about manufacturing the various parts as it went along, which just sounds amazing. Quite a jump from where we are with the 3D printing right now. We're going to be printing solar panels anytime soon.
No, and because that is partly due to the fact that solar panels are composed from a lot of different materials.
Right, yeah.
So you would need manufacturing capabilities for all these kind of components. It's the same as how one of the other challenges is how do we manufacture electronic circuits on board. There are technologies there. I mean, we're monitoring at the moment a few companies who are looking into these kind of applications is just to print circuit boards on demand, print electronic components on demand. That's far more in early stages than we are with metal and plastic printing.
But it makes sense, doesn't it? I mean, if you can establish yourself as the Intel of space, eventually once we start getting out there and more of these projects happen, you've got a captive audience. I mean, that's literally, that's absolutely fascinating. And of course, there's the asteroid mining stuff as well, the idea of latching onto an asteroid and just plucking out what we need from that as well.
Yeah. And there's companies who are starting on that. There are startups in the US who are already anticipating mining asteroids, mining moons, and they find themselves in quite substantial interest.
Yeah, it's fascinating, isn't it? I mean, it seems so completely far-fetched, but we seem to be jumping. We seem to be taking these sort of leaps ahead now with this stuff. So what's? I've kept you for so long. I'm sorry. But
It's okay.
What's next for you? Like, what is the next stage now? It's up there. It's printing. What would you like to see happen as the next stage for this?
Different ways. The first is we have to see whether we can be successful in completing all the 4 samples we were planning to do.
Right. How close to that now? Where are you at on that?
We're in the second one at the moment.
You're printing 4.
We're printing 4, and we believe with today's planning, we could be ready around April next year.
Wow. Okay.
And that's
space takes a lot of patience. That's like, you gotta have a certain zen to you. No wonder you're out there taking photos of wildlife. You need to chill out with this stuff.
The fact is that the printer is hosted in a rack. So here you see a photo of our colleague Andreas Mogensen, the Danish astronaut. And this is the metal 3D printer. Inside what we call an experiment rack, a cabinet. Right. And this is a cabinet which can support different kind of experiments. And from April 1st or from April onwards, we are expecting another experiment to be supported by that rack. So that means that we have to be ready by April.
Yank it out and get the new one in.
We're discussing a few options. Just remove it and trash it. So that means it's going into a supply vehicle and it will burn into the atmosphere. And because we've done all, we still have an engineering model on Earth. We still have a copy. Yes. But it's quite expensive to bring 180 kilos down to Earth.
Right. Yeah.
It's at this moment the indication I got it's between 50 and 100,000 per kilo.
Well, and I suppose environmentally it also makes more sense because you're trying to get that thing back down to Earth with the resources required.
It would be a lot. So we try to do the planning until that. Then we get the samples. We get them on Earth and we have to start processing. I saw a question on what is the differences between what you print in space and what you print on Earth. And that is, it's the best question. But I can't answer that. This is what we're going to find out in the next year. And then I'm happy to be joining you for a second time. Yeah. Then I can tell you a little bit about, this is really the results of what's the strength, but also we're going to look at, with an electron microscope, we're going to look at the microstructure. We're going to look at different material characteristics to get an understanding of, is there a difference? Maybe there is. And if there's a difference, is it better or not? Sometimes producing, for instance, proteins, other materials in space is better than on Earth because the lack of gravity. So the composition is
sort of down.
Exactly. So maybe we find it out in that way.
Who knows? We could be sending stuff up to space to get it printed properly.
People have been thinking about that. I know a project who is planning to print optical fibers in space because the quality is better there.
Oh, wow.
To be used for small distances with high throughput optical connections.
Really? I mean, wow. I can't get over the difference in the economy of getting stuff to and from space now has just completely changed since I was a kid.
It's changing.
It's become, we're not exactly at Uber Eats yet, but it's definitely feeling like especially, that SpaceX seems to have just revolutionized that stuff.
They definitely are, for instance, for the launching service, their services, I think they've been a game changer.
Mm-hmm. Yeah. But what's neat about this is you've taken it to orbit now. Basically it's like, all that, the biggest, most wasteful part of this is these giant rockets blasting stuff up in order to get us out of the atmosphere. If we can start building this stuff out in space, that's a whole other level.
There's, of course, a lot of debate and discussions around how and under what conditions you should use space resources like from a comet, from the moon, etc. There's quite a few treaties. So there's still a lot also on, and I'm not the expert there, but on the legal side, on the which arrangements have been made there. But the potential of building something in space using in-space resources is getting closer. And,
Absolutely.
it's being under investigation and development.
It's funny how we get in our own way, though, isn't it? That we're already trying to figure out who owns what and who's allowed to do what. One of the things that I had this horrible feeling of like we're doing such a horrible job of managing this planet that was literally designed for us. Like in that we are a part of this planet because it allows that. We've done such a bad job of that we've got sort of billionaires leaping into space in the hopes of going off to other planets and starting all over again, which just never made any sense to me because I just thought like surely the resources would be better spent making it work here. But there's also there's a wonderful term that was used the other day where they said like us going to other planets is a bit like we're the tendril. We're like an Earth tendril, like that. This is us. This is not yes, we're humans and all the rest of it, but we are representing a planet. We are a part of this biosphere. And perhaps we are that green tendril that is reaching out to these other planets. It just sort of changed the perspective for me. I suddenly went, okay, then maybe we're not the most horrible things in the universe, but perhaps we are that little sort of reaching tendril, which I think is just a wonderful image. I have eaten up so much of your time. This is so fantastic. Thank you so much.
Oh, you're welcome. It's a pleasure.
I cannot wait to hear what else happens with this. I really think people would appreciate the wildlife stuff. You got to come and talk to us about the wildlife photography at some point, too, because it's something that I've always been fascinated in, never had the patience for. Although I did once stand in a very mosquito-ridden bog for a while trying to record a frog making noises. So, I do have the patience when necessary and a lot of mosquito scars to prove it. And today, you're saying today or this week is ESA Day, where you open the place up.
We have an open days this weekend.
And is this can anyone book this, basically? Is it?
Yes, anyone can book this. However, I think being so short in advance of the open day, I think it's already fully booked, but I don't have an overview of that.
But like for next year or for future years, people should consider getting there and checking
an eye out. First weekend of October, it's the open day at ESTEC, and really you're then at the technological heart of ESA. Our headquarters is in Paris. We have establishments in the UK, in Italy, Spain, Germany. The technical heart is in the Netherlands. We already have the test facilities. You will see facilities which actually can simulate launch vibrations of satellites. They can do. We have an acoustic chamber where I would strongly advise you not to be in the acoustic chamber when it's working because you will survive only a few seconds.
Really?
Because the acoustic loads during a launch, the noise and the impact that has on the structure is huge. It's underestimated and not understood, I think, by a lot of people. But it's not only the acceleration of a rocket, but it's also the noise which is generated and the noise waves. I mean, it's like going to a concert and you feel the bass player in your stomach.
Yeah.
That's what happens to a rocket.
Oh, my gosh. Yeah, that's true. I mean, we just went to a Weezer concert and I was amazed at how I could feel everything. Things seem to be moving that I don't remember moving before. That's wow. So definitely going to suggest that if people get the chance to do this, I think you should set up like an ESA tour where you just go from each different part of Europe that houses some kind of ESA thing and eat lots of.
Make sure you include ESTEC because that's really where a lot of the projects are materializing. I mean, usually when a satellite is built in the European industry, like the Galileo satellites, I always call it the European GPS, the Galileo satellites, they're tested at ESTEC. So once they're built, they come to ESTEC and we do the environmental testing there.
Was JUICE there? The Jupiter? That one as well? Wow. That's one of my new favorite things to obsess about now, too. Even just how they get there is extraordinary. I always, the slingshot thing, I was like, yeah, they use the gravity and fly yourself off into space. I didn't realize you use it for braking as well. It's so genius.
That whole orbit calculations, it's an art in itself. How people do that.
It is it's a dark art of magical. I can't get my head around it. Although I can't get that. I can't, look, I want to see the installation manual for your 3D printer.
I will just show you because I didn't find the initial file, but I'm going to present about the 3D printer at the end of October on the International Aeronautics Conference in Milan.
Oh, cool.
And so I give you a sneak preview.
Ooh, here we go. Early access. Oh, wow.
So here you can see this is not what we have printed in space, but this is actually the part which we're printing now in space. But this is the installation of the 3D printer by Andreas Mogensen. And this is an image where I don't know why they included that, because they're really very rough with the.
I was going to say, you've got to be going like, what are you doing? Yeah.
They try to get the lid off, but also here you see that there are different angles because there's no gravity. So this is a 180 kilos beast, and they're handling it like a bodybuilder.
My God. I forgot about that. That takes the back-breaking work out of it.
Yeah.
But
so here you see that it's installed in the experiment cabinet. So here it's installed. There's a frame which basically mounts it into the rack.
Right.
And then the different like power, data, the cooling, the nitrogen, that's all connected to the cabinet. And then we start.
That's like a cable management nightmare.
This is the one which is printed in space.
Wow. So that's literally you doing it layer by layer.
Yeah, layer by layer, but this is accelerated. This is in the end. And I will let you know when it happens, because at some point you will see that there is. So you see it, the flashing?
Yeah. That's the heat.
That's what I was talking about, the heat.
Yeah. Interesting. And it didn't show up until it got further in and further away from the base.
Yeah. But
and even worse now. Look at that. And are you seeing an effect on the material in that? Surely there must be something.
Good question.
Well, you can't tell from the cameras.
We can see a little bit from the cameras, but basically we want to investigate it once it's back. And as it looks now, the sample, this printed sample, so the one which you see here held by one of the crew members, probably is going to be returned to Earth in November this year, so next month. And then it's going to ESA, and then we start the investigations. And at that moment, we are also much better positioned to answer questions like, does this heating affect the quality of the material printed?
Well, then it's a great excuse to have you back then. Once you've done all the fancy chats, you can come back.
Yeah, now the lab work is starting.
So will you get to hold it? Will you get to go like that's...
I will get a selfie with it. Yeah. For sure.
Yeah.
100% sure.
Is there fear of contamination and stuff? You'd have to use gloves anyways, but is it something that would be out in the air like that? Does it have to be protected? I just curious.
We do not expect that it will make a lot of difference, because also the ones we printed on Earth are handled in open air in the lab, of course, in lab conditions. So controlled temperature, controlled humidity, etc.
Right.
But yeah, with using the gloves, we actually prevent the contamination by hand.
Just the oil. And so
I will have to wear the gloves, but yes.
I got to see the selfie. Yeah, that's got to be, that's like your world.
I will not leave before.
Yeah. That's like a soccer trophy thing. You want to get it
I think there will also be a bit of celebration when we get it in the lab here.
Yeah, no kidding.
For a lot of people, it's a large team. It's different organizations working, and within this different organization, there are different people working, and everyone together. We have people on the engineering side, the operations side, the crew training. So everything has to work together to make sure that this is getting this result. So we also will make sure that as soon as
there'll be a lot of selfies.
There will be a lot of selfies. Yeah.
Let me ask you one final question, if you don't mind. If someone is let's say in high school right now or whatever, and they're thinking oh my God, this is amazing. Are there any advice, anything, are there specific things that you did that you think helped you get where you were, state of mind or study habits, or even just what you focused on? Anything in particular?
I think the advantage of working in the space domain is that we do employ a lot of different disciplines. We also have legal departments, we have policy departments, so we have operational colleagues who are working on console to direct the astronauts and support the astronauts in their daily operations. Of course, a large part is engineering. So, of course, as I would always advise first of all, you really need to want it and to have the drive to do it. Yeah. I think that's what I experienced myself. And from that drive, I started to go to university and study aerospace engineering.
Where did you study?
In the Technical University of Delft, which is quite renowned aerospace engineering. But quite honestly, the reason why I joined ESA 15 years ago was not because of the engineering skills, but because I was working on how do you employ satellite data. So data from Earth observation satellites, from telecom satellites, from GPS, how do we benefit from that on Earth? And how do we develop services based on that. That was the reason why I started here. But then there was a vacancy for working on the space station, and that was kind of, for me, they're doing Earth observation, they're building rockets, they're building satellites, they're building satellite navigation, science satellites. So we cover the whole spectrum of space, including how do we benefit from it on Earth.
And of course, every single aspect of that requires communication, because it's not like there's no cables. It's all about how do you get the data back and forth.
Exactly. And for me, it goes without saying, because it's like natural. And I think you will agree with that, and Agne will also agree with it. It's international. It's multidisciplinary. I mean, along the way, you get to know a lot of people, visit a lot of places, and it really opens a world.
Yeah.
And at the same time, the space world. I mean, I'm going to IAC. I already know I will meet a friend of mine there I haven't seen for 30 years.
Ha.
So it is, and yeah, that's also one of the aspects. It's the network keeps the drive alive.
Right. And it sounds like you are interested in all aspects of this. I mean, there's nothing that doesn't sound fascinating. Even the biology stuff.
The underlying science is sometimes the most fascinating.
So maybe curiosity is the key.
Curiosity, yeah. Yep.
That's fantastic. Look, Rob, thank you so much. Everyone in the chat, thank you for your fantastic questions. I'm sorry we didn't get to all of them, but I feel like we've covered everything. Is there anything, Agnes, is there anything that you think we should be covering? I'm also going to say a huge thank you to Agnes as well, who is a shadow agent working in the background. She didn't want to be on camera, but she has been absolutely instrumental in making this happen, and is even talking about setting me up with some more people to talk to. I can't imagine them being as interesting as you, Rob, but I'm sure they'll try.
Oh, there are definitely.
You know some of these people too, right?
Yeah, exactly.
All good and a heart. There you go. I think we're in good with Agnes as well. Rob, again, thank you so much. Everyone, thank you so much. This is like, I'm with Genius. This is what I pretend to be smart on television, and then I get to actually talk to people who know what the hell they're talking about and are making a huge change. And I thank you so much, Rob, for your enthusiasm, all of this. It's just absolutely.
It's been a pleasure. And also thanks for those watching, and I would say the very good questions. And it's been a pleasure to share this with you. If you're asking what's fun about this job,
this is part of it. Yeah, there you go.
This is part of it.
That's where our jobs actually meet. To me, this is the fun. This is what I love about the fact that by pretending to be in space, I get to talk to people who are actually working out there. That's amazing. All right, so I will wrap it up. I will let you go. You've been more than generous enough of your time. Thank you so much. How was that for the first I'm with Stargate Genius chat? Rob, was a pleasure. What a wonderful, wonderful chat. I cannot wait to have him back. Agne, again, thank you so much for making this happen. Thank you all for being there, for your fabulous questions, for your enthusiasm and joy at the 3D printing metal in space. And until we meet again, I will say, be brave, be kind, be brilliant, cheerio, and huzzah!